Good afternoon, students. In the last class, we discussed the problems based on kinematic equation of motion. Now, I am going to explain a small concept based on same kinematic equation of motion, that is called Galileo law of odd numbers. Galileo law of odd numbers. So, what this law explains is very simple, that the distance travelled by a freely falling body in 1, 2, 3, 4, 5 seconds, like this. So, what is the distance travelled by a freely falling body in 1, 2, 3 and so on is. So, the statement is what? The distance travelled by a freely falling body in 1:2, 2:3 and so on n seconds is, he calculated the distance as 1:4:9:16 and so on n square. So, that is the statement given. Let us take the proof. What is that? Distance. I am writing the proof. No need to derive the proof, but you should know how it came, right? Travelled by freely falling body. Distance travelled by a freely falling body. First, what is the formula? Basic formula is S is equals to ut plus of at square. Since it is a freely falling body, initial velocity is 0 and it is falling under acceleration due to gravity. Substituting these two things, what you get? S is equals to of gt square. For example, if t is equals to 1, then distance travel is S1 is equals to of g into 1 square. So, what you get? Of g into 1, right? Similarly, after 2 seconds, S2 is equals to of g into 2 square of g into 4. In the same way, if t is equals to 3 seconds, S3 is equals to of g into 3 square, that is equals to of g into 9. If you take like this, if you take for nth second, Tn is equals to Sn is equals to of g into n square. So, of g n square. If you take the ratio, because we take the distance, right? The distance travelled by a freely falling body in 1:2, 2:3 and so on n seconds is 1:4:9:16 and so on n square. So, we can write this as S1 is to S2 is to S3 and so on Sn is equals to, what is S1? Of g into 1 is to of g into 4 is to of g into 9 and so on of g n square. So, what is the thing that get cancelled in each case? Of g. So, what you can get? 1:4:9 if you take for 4, 16 and so on n square. So, the distance travelled by a body in 1:2, 2:3 seconds is, and so on Sn is what? 1:4:9:16 and so on n square. So, this is the formula, first statement of law of Galileo of odd numbers. Next, the same concept can be applicable for distance travelled by a body in nth second. Let us apply for that one. Same thing, what? The distance travelled by a body in first, second, third and so on nth second. The distance travelled by a body in first, second and third and so on, nth second is 1 is to 3 is to 5, 7 and so on, 2n minus 1. So, same thing, distance travelled by body in nth second is what? Sn is equals to u plus g by 2 into, sorry, a by 2 into 2n minus 1 ma. So, that is the distance travelled by body in nth second. For a freely falling body, initial velocity is 0 and acceleration due to gravity is what? Acceleration is due to gravity. Now, we can consider at t is equals to 1 second, first second, S1 is equals to, the formula is what? Sn is equals to g by 2 into 2n minus 1. At t is equals to 1, substitute n is equals to 1, nth second, right? N is equals to 1, S1 is equals to g by 2 into 1 minus 1, nothing but g by 2. At n is equals to 2 seconds, S2 is equals to g by 2 into 2 seconds, 2 into 4 minus 1, nothing but g by 2 into, 2 seconds, right? 2 2s are 4, 4 minus 1 is 3. At n is equals to 3 seconds, S3 is equals to g by 2 into 3 minus 1. So, what you get? G by 2 into 5. If you extend the same formula for at n is equals to nth second, Sn is equals to g by 2 into 2n minus 1. So, now the distance travelled by body in first, second, third and nth second is what? S1 is to, S2 is to, S3 and so on, Sn is equals to what? G by 2 into 1, G by 2 into 3 is to G by 2 into 5 and so on, G by 2 into 2n minus 1. Cancel G by 2 on all sides, what do you get? S1 is to, S2 is to, S3 and so on, Sn is equals to 1 is to, 3 is to, 5 is to and so on, 2n minus 1. So, these are the two formulas that are very helpful to answer the question. That is what? Distance travelled by a freely falling body in first, second, third second and distance travelled by body in 1 is to, 2 is to, 3 is to and so on, n seconds. Next concept is relative velocity. We know what is velocity? The displacement by time taken is called velocity. What is relative velocity is? So, first before saying that, I will give an example that you are sitting in a train in railway station. There are two platforms are there. You are in train A, sitting in the train and your friend is sitting in the another train B. Now, the train starts, both moving same velocity, same direction. What we feel? The train is moving? No, we feel that we are at rest because we are sitting near a window. Exactly, our friend is also sitting in the opposite window. So, after half an hour or so, you are appearing same. What we feel? We are at rest because both are moving with same velocity along same direction. If you take the same example, you are in the train A and the train B is moving in opposite direction. Even though the train is moving with 30 km per hour and our train is moving with 40 km per hour, we feel that the other train is moving so fast. And the people in train B also feel the same thing, that the opposite train is moving with high velocity. So, this is called what? Relative velocity. Means we are comparing our velocity with respect to another body, or we are comparing our velocity with another object. It's called what ma? Relative velocity. So, we can say that relative velocity as the velocity of one object, the velocity of one object with respect to another. With respect to another is called relative velocity. Okay. So, let us take an example that here velocity A is moving with velocity VA and B is moving with some velocity VB. Now I want velocity of A with respect to B. Here both are moving along same direction. Then the formula is VAB is equals to VA minus VB. Velocity of A with respect to B is called what ma? VA minus VB. If you want velocity of B with respect to A is what? VBA is equals to VB minus VA. For example, both objects I said na, both trains are moving along same direction with same velocity. If A and B are moving with same velocity, along same direction, same velocity along same direction, then what happens? VAB or VBA, if you take anything, what you get? VA minus VB. Here what we said, that A and B are moving with same velocity along same direction, then what it's explained, that VA is equals to VB. If we substitute VA is equals to VB, what you get? 0. Means we feel that we are at rest, actually we are not at rest. If we compare with other, both are along same direction, so that we feel we are at rest. Okay. Next, for example, if A is moving this direction, this is VA, and B is moving in opposite direction. So if two bodies are moving along same direction, what is the formula? VAB is equals to VA minus VB. So this you consider as positive and this you consider as negative. What happens is, if, or we can write as velocity of A with respect to B, VAB is equals to VA plus VB. If you want for VBA, we can write as minus VB minus VA. So what do you get? Minus of VB plus VA. For example, both are moving the same velocity. If VA is equals to VB, then what happens? VAB is equals to 2VA or 2VB. VBA is equals to minus 2VA or 2VB. So we feel that the other object is moving with double than our velocity, they also feel the same thing. So if you do one problem based on relative velocity, you can get clarity. So what is the relative velocity? The velocity of one object with respect to another is called relative velocity. If both are moving along same direction, VAB is equals to VA minus VB. If they are moving in opposite direction, VBA is equals to VB minus VA. If both move same velocity, the relative velocity is what? 0. If objects are moving in opposite direction, then relative velocity is what ma? VA plus VB. Okay. See, let us solve a question, two questions based on relative velocity, then you can get clarity. What the question is, a jet airplane travelling at a speed of 500 km per hour ejects its products of combustion at the speed of 1500 km per hour relative to the plane. What is the speed of the latter with respect to an observer on the ground? So they clearly given that there is a jet plane, it is travelling with a speed of what ma? 500 km per hour. So velocity of jet plane. What is the velocity of jet plane? Vj equals to, assume that 500 km per hour. Okay. Ejects its products of combustion at the speed of 1500 km per hour with respect to jet plane. You know that this is a jet, assume that it is moving with the speed of 1500 km per hour, it emits the combustion, its products of combustion with a what speed of 1500 km per hour with respect to jet plane. We have to consider this one. they given the velocity of combustion with respect to jet plane, not velocity of combustion. So what we can write here? Velocity of combustion with respect to jet plane. So VJC is equals to what, ma? 1500 kilometer per hour. Now, as we know that here jet plane is moving upward direction, its products of combustion moving coming in backward direction. So both are moving in opposite direction. So we can write from relative velocity VJC, because both are moving in opposite direction, VJ plus VC, right? So what is VJC means? Velocity of jet with respect to the combustion, or velocity of combustion with respect to jet is what? 1500. As they given velocity of jet is how much? 500 plus velocity of combustion, that is velocity of combustion or latter equals to how much? 1000 kilometer per hour. So this is the velocity of combustion. So this way to calculate the relative velocity. Understood? Next one, same question, means same concept. Let us take the question. What is the question? See, a van moving on a highway with a speed of 30 km per hour fires a bullet at thief's car, speeding away in the same direction with a speed of 192 km per hour. If the muzzle speed of the bullet is 150 meter per second, with what speed does the bullet hit the thief's car? So, chasing scene, right? What that? Thief's car is chasing by police van. The velocity of police van is how much? 30 km per hour. What is the velocity of thief's car? 192 km per hour. Is it possible to chase the car? Police are moving 30 km per hour and thief is moving with 190 km per hour. So, it doesn't happen. What they have done? That's why he fired a bullet with a speed of 150 meter per second. The question is what? With what speed does the bullet hits the thief's car? We should convert kilometer per hour into meter per second, because here they given meter per second. First, what they given? Velocity of police van. VP is equal to how much? 30 km. So how to convert? 5 by 18. 6 3s are 6 5s are 5 into 5 25 by 3 meter per second. Next, similar way, velocity of thief's car. VT is equal to how much? It is moving high speed, 192 into 5 by 18. 6 3s are, again 6 3s are 2s are, right? 32 into 5, 5 2s are 10, 5 3 15. So 160 by 3 meter per second. Now, velocity of bullet. Here you should notice that the velocity of bullet, since the bullet is fired from police van, we should consider velocity of police van as well as velocity of bullet, right? So what is the velocity of police van here? 25 by 3 plus 150. 3 into 150, 450. So you get finally 475 by 3 meter per second. So now his bullet is moving with what speed? 475 by 3. So assume that this is police van. They fired a bullet towards the thief's car. So both are moving along same direction, right? So VBT, velocity of bullet with respect to thief's car, is equals to what? VB minus VT, because both are moving along same direction. What is velocity of bullet? 475 by 3 minus velocity of thief's car. How much? 160 by 3. So 475 minus 160 divided by 3. How much you get? 5 1 3 15 by 3 3 ones are 3 1. So the velocity with which the bullet hits the car is what? 105 meter per second. So this is about relative velocity and the question is based on relative velocity. Thank you students.